When you want to find a limit, this is the limit as x approaches 2 of this rational function. The first thing you do is simply plug in 2, because when you plug in 2, it could work. So let's check. If I could plug in 2, I am done with this problem. So when we plug in 2, we get negative 3 times 2 squared plus 6 times 2 over 2 times 2 squared minus 9 times 2 plus 10. So we do the math here, and what we end up with is negative 3 times 4 plus 12. And down here we get 2 times 4, which is 8, minus 18 plus 10. All right. And there we get negative 12 plus 12, that's 0 over 0. 0 over 0 is called undefined. This does not exist. So since I plugged in 2 and it does not exist, this method doesn't work. Okay, so I can't, the limit is not just plug in the answer, get the answer. I have to now use an approach to try to find the limit. I could try to graph it, if you're great at graphing. I could try to crunch it from both sides with the table, but I'm going to do something analytically. And what you're going to do here is factor. We're going to use factoring, because if I factor top and bottom, something might cancel. And that's what we're looking for. So I'm going to do the limit as x approaches 2, and I'm going to factor top and bottom. So to factor the top, do you see a GCF of 3x? You could also see it as negative 3x. I tend to like to not have negative lead coefficients. So what I'm going to do is I'm going to pull out a negative 3x. It's just a thing I like doing instead of having a positive 3. I don't want this right here to be a negative. So I'm pulling out a negative with it. Okay, when I pull that out, I'm left with what? Well, negative 3x times what gives us this? And then negative 3x times what gives us that? That's kind of what we're thinking. So let's see. Negative 3x, wouldn't it be x here? And wouldn't this be a negative 2? Let's think about that. Would this times this give us that? And would this times this give us that? So we factored the top. Okay. Now the bottom factoring is a little bit trickier. There's no GCF. So the way I factor, there's lots of ways to factor it, is what I do is I take the front and back and I multiply them. You get 20. All right? Then you take the middle and you put it on the bottom. All right? And then you're looking for two things that multiply to get the top and add to get the bottom. So if we think about that, it's not negative 4 and negative 5. So negative 4 and negative 5. Now, there are lots of ways to factor this. This is the way we've recently been doing it more, is we leave these two. So we leave those. So we have 2x squared, and we have the plus 10 at the end. But what I'm going to do is this negative 9, I'm going to break it up to negative 4 and negative 5. So it's a negative 4x minus a 5x. Again, so what I did is I rewrote this, and I changed negative 9x to be a negative 4x and a negative 5x. I just changed it into two parts. All right? Then what I'm going to do, for this, I'm going to pull out a GCF. It's called grouping. So for that piece, if I pull a 2x out, I'm left with x minus 2. And for this second part, I'm also going to pull a GCF out of negative 5. And if I pull a negative 5 out, I'm left with x minus 2. And what you see here is something called grouping. Do you see how they both have an x minus 2? I can pull that out now, because both parts have an x minus 2, leaving you these behind. When you pull the x minus 2 out of both parts, leaving those behind, I have 2x minus 5. So all that said is I can now take this and write it right there. X minus 2, 2x minus 5. And what I can do is I can cross out these, because anything over itself becomes a 1, which disappears when you're multiplying. So really, the limit as x approaches 2, the new function is now negative 3x over 2x minus 5. What I'm trying to point out here is this function is the same as this function is the same as this function graphically. Now, this function is slightly different, and we'll learn about that. There's something very small different between this and this. The moment you cancel something out, I make a very, very small change on the graph. Very minute, but that change is very important. But we can use these two functions because they're practically the same. Now, what we're now going to do is simply now plug in 2, like we did right here. See how we plugged in 2 here? Now watch what happens when I plug in 2 now. It's kind of cool. I plug in 2, so I now have negative 3 times 2 over 2 times 2 minus 5. And watch what happens. I now have negative 6 over 4 minus 5, which becomes negative 6 over negative 1, which becomes 6. So guess what? My answer is 6. The limit as x approaches 2 of this is actually approaching 6. Because what I did is this function had an error, had no value. But I created another function almost identical to it that I could actually plug the number in and get 6. What you'll learn in the future of how did that work is this function has a little hole at 2. This function is the same exact function with the little hole filled in at 2, thus creating the value 6. So you're creating a function that this function is the exact same graph with the hole that this one had filled in. So you kind of patched up the hole like a tire. This one has the little hole. Oh, it's not working. So we patch up the tire. Now we can find the limit, the value, because you cleaned it up. Again, these are different functions, but almost identical graphically.